Picture this: the heart of our solar system, a celestial furnace, burning with a force so immense it powers life on Earth. The Sun, a colossal fusion reactor that holds sway over the entire solar system. It is the reason we have warmth, light, and energy. But what if we could somehow replicate this enormous, uncontrollable force here on Earth? What if, through human ingenuity, we could bring the energy of the sun to our doorstep? Would we be able to recreate the sun's fire, its power, and its brilliance in a controlled setting? And if we succeeded, what impact would it have on our planet, our resources, and our future? The questions are as intriguing as they are profound. Let's embark on an incredible journey and explore the boundaries of science, imagination, and the ultimate challenge of building a second sun on Earth. The sun is, by far, the most powerful object we encounter in our daily lives. It's the center of our universe, a massive star that provides the energy needed for life on Earth. But it's more than just a giant light bulb hanging in space. It's a cosmic furnace. The sun is composed primarily of hydrogen, and inside its core, the temperature soars to over 15 million degrees Celsius. It's here, under unimaginable pressure, that the sun performs its most vital function, nuclear fusion. In the heart of the sun, hydrogen atoms collide with such force that they fuse together, creating helium and releasing vast amounts of energy. This process is known as nuclear fusion, and it's the same process that powers hydrogen bombs. The energy released from fusion is in the form of heat and light, which travels outwards, eventually reaching Earth as the warmth we feel on our skin and the light we see every day. This constant, self-sustaining reaction has been happening for about 4.6 billion years, and it's estimated that the sun will continue to burn for another 5 billion years before it eventually transforms into a red giant. But for now, it burns brightly, sustaining life and shaping the rhythms of our world. This is the very process we would need to replicate in order to create a sun-like effect on Earth. The task of replicating the sun is no small feat to even begin. We would need to recreate the extreme pressures and temperatures that occur inside the sun's core. Achieving the same intensity of heat and pressure here on Earth is a monumental challenge. While we know that fusion is the key to the sun's energy, scientists have struggled to replicate it for decades. The problem is simple, yet complex. How can we contain and control a force that could easily annihilate anything in its path? In our attempts to simulate the sun's fusion process, we turn to fusion reactors. These reactors aim to recreate the process of nuclear fusion that powers the sun. However, achieving this on Earth is no small feat. A successful fusion reaction requires extremely high temperatures, on the order of millions of degrees, far hotter than the surface of the sun itself. We use devices like tokamaks and laser confinement to try and trap plasma at such temperatures, but the challenge is always the same. How do we control such intense energy without it escaping? What makes this process so difficult is that we're not just recreating a small-scale fire or even a large furnace. We're trying to replicate a cosmic-level energy release, a force of nature that powers stars. The energy produced by fusion is so vast that even the smallest misstep could lead to catastrophic consequences. And we're talking about an unstable fuel, hot plasma, which behaves unpredictably. The task is not just about creating a reaction, but about containing it safely without it turning into something uncontrollable. Let's imagine, for a moment, that we've overcome the scientific hurdles and managed to replicate the fusion process on Earth. What would we need to bring this vision to life? The scale of the sun's power cannot be overstated. The sun is so massive that it dwarfs our planet in ways we can barely comprehend. Its energy output is 3.8 times 10 to the power of 26 watts, far greater than anything humans have ever produced. To replicate this level of energy, we would need to produce a tremendous amount of fuel, a constant supply of hydrogen, the same element that powers the sun. Perhaps we would look to outer space for this fuel, mining hydrogen from the solar wind or the interstellar medium. We would need vast amounts of this raw material, and its procurement would be a challenge in itself. Then, there's the containment. The sun's energy is held within a delicate balance of temperature, pressure, and gravity. We can't replicate the sun's gravitational pull here on Earth, but we could use magnetic fields to try to mimic this pressure. Powerful magnetic confinement would be required to hold the plasma in place long enough for fusion to occur. But even with these magnetic fields, the sheer scale of the energy output would be an insurmountable challenge. And then there's the energy itself. If we were able to replicate the sun's fusion, we would be tapping into an unimaginable force, energy that could power the Earth for centuries. But we'd have to find ways to harness that power. Energy that intense could easily destroy everything in its vicinity if not handled with the utmost precision and care. We'd need new materials, new methods, and new technologies to safely harness and use it. But let's step back for a moment. What happens if something goes wrong? What if the containment system fails? The energy of the sun is destructive, capable of incinerating anything it touches. The sheer heat and radiation would make the surrounding environment uninhabitable. A single malfunction in the containment field could lead to catastrophic results, potentially altering the very fabric of life on Earth. Even if we do succeed in containing the energy, what are the unintended consequences? The sun provides us with light and warmth, but it also regulates the Earth's climate. Could creating a second sun on Earth upset this delicate balance? Could the immense radiation change the composition of our atmosphere? Could it trigger a climate disaster, disrupting ecosystems and making large portions of the planet uninhabitable? Perhaps, after all, the real solution lies not in replicating the sun, but in harnessing its energy directly. We already have the technology to tap into the sun's power in a much safer and more sustainable way. Solar panels, for instance, are already capturing the energy of the sun and converting it into electricity. The transition to renewable energy is well underway, and the promise of solar power is limitless. Rather than risking the creation of a second sun, we can learn to work in harmony with the first. Solar farms, wind energy, and other renewable sources give us a clear path forward to a clean, abundant, and sustainable energy future, without the risks of creating a man-made star. The question we must ask is not whether we can build a sun, but how we will choose to use the sun's power responsibly. Our future lies in understanding, respecting, and creatively using the energy already available to us. And who knows, one day, we may look back at the idea of building a sun and marvel at how far we've come, learning to harness its power without trying to replicate its dangerous majesty.